set A is equals to A is a matrix of order n cross n such that a diagonal matrix right and A square is equals to A. Question is that you are asked to find what is the cardinality of A. What is the cardinality of this? What is the cardinality of the set? Right? A is a set of all matrices such that A is diagonal and whose the square is itself. What is the cardinality of the set S? How many matrices are in S? Right? So you can start for this. You know, when I take a matrix in S, that should satisfy this both conditions. That must be diagonal and that must be whose square is equals to A. That means, you know, actually my matrix is n cross in order. For sake of our convenience, you can take, for example, A is equals to dia of A1, A2, AN, right? A1, A2, AN, because actually A is a diagonal matrix. A can be assumed that A is equals to dia of A1, A2, A3, AN. You know what you're given is A square is equals to A. Therefore, you can have actually A square is equals to A. What is A square? What is A square? A square is equals to dia because it is actually diagonal matrix. Therefore, A1 square, A2 square, AN square. But you know that A square is equals to A1 square, A2 square, going on AN square. But what is A? A is a diagonal matrix. This is diagonal of A1, A2, AN. Therefore, you know, this is what actually this is A1 0 0 0 0, A2 0 0 0, 0 A2 0 0, going on 0 0 0 AN equals to A1 square 0 0 0, A2 square 0 0, going on 0 0 AN square, right? Therefore, two matrices are equal if and only if their corresponding elements are same. Therefore, A square is equals to A1 and A2 square is equals to A2, going on AN square is equals to AN, etc. Therefore, that means each A square is equals to AA is 2 for every I equals to 1 to n. Therefore, AA into AA minus 1 equals to 0, right? So therefore, either A equals to 0 or because each A is a real number. So A minus 1 equals to 0, that means A equals to 1. Therefore, each A has two choices, either 0 or 1, either 0 or 1, right? For each I equals to 1 to n. Each element can be either 0 or 1. So each AI has two choices. But what is your matrix? Your matrix is A1, 0, 0, 0, 8, 0, A2, 0, 0, 0, 0, 0, 0, 0, 0, AN, right? So this element has two choices, 0 or 1. This element has two choices, 0 or 1. Similarly, this element has two choices, right? So what is the cardinality of S now? So first element can be filled by two choices. Second element can be filled by two choices. Going on, 2 into 2 into 2 into 2, going on 2 power n. So the what is the cardinality of S? 2 power n, right? Question. Right? Suppose you are given actually 1 by 2, 0, 1 by 2, 0, 1, 0, and 1 by 4, like 3 by 4, 0, right? What is you're asked to find sum of elements of each row of A power 100, right? You are given a matrix A equals to 1 by 2, 0, 1 by 2, 0, 1, 0, 1 by 4, 3 by 4, 0. You are asked to find sum of elements of each row of A power 100, right? So what is the trick you are going to get is, you assume that here, look at this row, What is the sum of elements of the row? First row, 1 by 2 plus 0, 1 by 2, that is equals to 1. What is the sum of elements of this row? 0 plus 1 plus 0, that is 1. What is the sum? 1 by 4, 3 by 4 plus 0. That means 1 itself.
1.
Therefore, what you observe is sum of sum of elements of each row of A, each row of A is 1, right? So sum of, there is a formula, sum of elements of each row of A power 100 is 1 power 100. That is actually 1. Is it clear? So what is the formula you notice? So look at the natural, in general, right? Suppose your matrix is A1, A1 2 going on A1n, A21, A22 going on A2n, going on AN1, AN2 going on, or else AM1 for sake of yeah, AN1, AN2, ANN, right? When you're given this square matrix, when you're given a square matrix of n by n, right? So what is the sum of these elements of first row? Sum of the elements of the first row is simply denoted by A11 plus A12 going on A1n, but this can be rewritten as summation j equals to 1 to n A1j, right? Similarly, this can be rewritten as A21 plus A22 going on A2n. This can be rewritten as summation j equals to 1 to n A2j, right? This means what? This sum of, what is this sum? This sum of elements of second row of the matrix A, right? What is this sum? An1, An2, An3, Ann. That means what? Sum of elements of nth row of A. That means what? This is nothing but j equals to 1 to n A and j, right? So this is nothing but what? This is nothing but sum of elements of first row of A. This is nothing but what? Sum of elements of second row of A, right? This is nothing but sum of elements of nth row of A, right? So suppose you're asked to find sum of elements of each row of suppose A square. This is a general case. So sum of elements of each row, that means what is the general element of A square? The general element of A square is nothing but what? This is my general element, typical element, right? What is the typical element formula? This can be rewritten as summation k equals to 1 to n. This is ikth element. It is like looking like A into A matrix. This is nothing but what actually? This is nothing but exactly, precisely. This can be rewritten as A into A. This is looking like A into B. Ijth entry of A into A. Ijth entry of A into A is nothing but I summation k equals to 1 to n. Ikth entry of A into kth entry of J, right? But what you require, actually, you require to find each row. You require to find sum of elements of each row of A square. So that is the formula is j equals to 1 to n. J equals to 1 to n A square Ij equals to summation j equals to 1 to n, summation k equals to 1 to n Aik into Akj, right? Therefore, this is a finite sum. We can interchange it. This can be rewritten as summation k equals to 1 to n, I equals to 1 to n, j equals to 1 to n, kj. What is this sum? This is what is it? This notation already told you. This is a notation for sum of elements of ith row of A. What is the notation of this? Sum of elements of kth row of A. But your given is that actually sum of elements of what you are given. Actually, your given is that suppose you are assuming that suppose if the sum of elements of each row of A. Suppose you are given sum of elements of each row of A is K. You're asked to find sum of elements of each row of A square, right? So sum of elements of each row is, so you're using some different notation. Take different notation because I'm using K equals 1 to here. So you can take suppose P, or else we can take some L notation L, right? So this is sum of elements of ith row of A. That means what? L. Sum of elements of kth row of A. This is also L. So L into L, L square, right? That means sum of elements of each row of A square. Each row of A square. What is it? L square, right? Similarly, sum of elements of each row of A cube. What is that? Anybody? L cube. So by induction, sum of elements of each row of A power. Suppose you can take A power m. What is it?
L power
m.
L power n.
Right? If sum of elements of each row of A is L, right? So this is what actually formula for that. Sorry. Very, very important formula, right? Suppose you are given a problem like this. A equals to suppose 1 by 2, 1 by 2, 1 by 2, 1 by 4. You can take 1 by 4, 0. This is 1 by 3, 0, 1 by 3. This is 1 by 3, 0, 1, 0, 0, 1 by 2, 0, 1 by 2, 0. Suppose you are asked to find sum of elements of each row of A power 2022. Right? Just what is the formula I'm telling you? Look at the sum of row. What is that? 1 by 4 plus 1 by 2 plus 1 by 2. What is this? 1 itself. What is this? 1 by 3 plus 0 plus 1 by 2 plus 1 by 2. What is the sum? 1. What is the sum? 1. What is the fourth row sum? 1. So sum of what you observe? Sum of elements of each row of A is 1. Understand? Sum of elements. What you observe? Sum of elements of each row of A. What is this? 1 you are getting. So what is the formula? 1 power 2022. That means 1 each. Is it clear?
First row sum 1 by 2, 1 by 4, 1 by 4 రాయాలి. 1 by 4, 1 by 2.
1 by 4 rasana. Yeah. This is suppose you can take the replacement 0. You can take 0. That's it. Okay.
Okay.
Or you can replace anything. Right? Suppose. So next argument. Suppose you are going to take suppose you are asked to find. See, you are asked to find what is the sum of problem number 2 for the same problem. A is equals to, right? 0, 1 by 2, 1 by 2, same problem. 0, 1 by 3, 0, 1 by 3, 1 by 3, 0, 1, 0, 0. This is 1 by 2, 0, 1 by 2, 0. Okay. Suppose you're asked to find sum of all elements. sum of all elements of, what is it? Suppose A power 2022. Anybody? Sum of A.
4.
4. Right, good. Right, what is the best way? Sum of each row is actually 1. You're getting. What you're getting actually? Sum
By
of
2.
elements of each row you're getting. What is each row of A power 2022? 1. How many rows you are? 1 row, 2 rows, 3 rows, 4 rows. Therefore, sum of all elements of A power 2022 is 4 into 1, because this row sum is 1, this row sum is 1, this row sum is 1. A power 2022 sum is 1, this also 1. So 1 plus 1 plus 1 plus 1 plus 1, that means 4 times, that is equals to 4. Right? So in general, suppose you're going to give a problem 1 by 3, right? Or else, yeah, in general, you need to write it. In general, notice if sum of elements of each row of A, it is that A is n by n matrix, is L, then sum of A part, just wait. Right, sum of elements of A power, suppose you can take M. What is the formula is total number of rows into, what is this? L power M. L power M. Total number of rows. What is this actually? Total number of rows. Number of rows into L power M. Into L power M. Right? Suppose you are given a question like this. Suppose you are given example A equals to a matrix of 5 by 5 such that sum of elements of each row of A is 2. Then what is the sum of elements of A cube? Yeah, what is the answer? Anybody? What is the answer?
8 into
Right.
8 into 3. 8
So
into 5.
total number of rows into 2 power 3. That means 8 into 5, that is nothing but 40. So this is very important question. Right? Suppose you're asked to find, suppose you're given a question like this. A is equals to 0, 1, 1, 3, right? 0, 1, 0, 2, 1, 0. What is the sum of elements of A power 3? Right? So your formula does not work, because actually this row sum is actually what? First row sum is 5, second row sum is actually 1, second, third row sum is actually what? 3. So it does not work. Right? Now what you do is look at the column sum. Column wise sum. This sum is actually 3. 1 plus 2 is equals to 3. This sum is actually what? 3. This sum is actually what? Third column sum? 3. Same idea. So sum of elements is actually sum of elements of each column of A is 3. Therefore, what is the sum of elements of A cube? Number of rows. This is 3 by 3 matrix. Number of rows into 3 power 3. That is 27 into 3.
81.
So what is the formula? Same formula. What is the notice for column? What is the notice for column? What is the column notice? If sum of elements of each column of A is L, you are asked to find sum of this first one, sum of elements of each column of A power M is equals to L power M. Second one, sum of elements of A power M. What is that? Number of, suppose it is n by n matrix, number of rows or columns into number of columns into L power M. Is it clear? So this is what actually formed. Right. Next is submatrix. What is that? Is it audible? Hello?
Okay, sir.
Yes. If this column sum is not see, suppose if your row sum is not work out, therefore look at the column sum. That is a trick. Understand? If the row sum is not equal, what you do is that look at the column sum. If the column sum is not permitted, what you do? Look at the row sum. Is it clear? Okay. Next is submatrix. Before submatrix, there is actually, I forgot to tell you something. Generally, in general, look at this A. Is it true actually? A plus B whole square. Suppose A and B are comparable, comparable. Whenever A and B are comparable, does it mean that A plus B whole square is equals to A square plus 2AB plus B square? Is it true in general? Is it true?
No, sir.
No. Right? Need not be true. Actually, in general, it's not true. Can you get let's take one example? So 1, 1, 0, 0. You take B equals to 1, 1. This is very, very important note actually, because I'm going to tell you whenever I deal with inverse matrices. So therefore, whenever A equals to 1, 1, 1, 1, 0, 0, B equals to 1, 1, 0. What is A plus B? A plus B is equal to actually what? 2, 2, 0, 0. What is A plus B whole square? A plus B whole square is equals to 2, 2, 0, 2, 2, 0, 0. That means this is 4. This is also 4, 0, 0. What is A square? A square is nothing but what? 1, 1, 0, 0, 1, 1, 0, 0. That is same as saying that 1, 1, 0. This is same as saying that A. Similarly, B square also same B. What is A square plus B square? What is A square plus B square? It's nothing but what? 2, 2,
0, 0.
0, 0. What is 2AB? You can take a different example. Actually, this example doesn't work. Maybe it seems like that. So what is 2 into AB? Look at this. 0, 1, 0, 0. This 1, 1, 1, 1, 0, 0. But what is this? This is nothing but actually what? 1, 1, 1, 0, 0. It's the same as saying that. Yeah, I think this example doesn't work. You can take different example. In general, here actually what happens here? A square plus B square plus C square 2AB is same as saying that actually what? Look at the same 4, 0, 0, 0. So actually both are same, but this example doesn't work. You can take non-trivial example. You can take non-trivial example. Right? You can take this. See, why I'm taking this, but for simplification, or you can take anything. 1, 2, 3, 4. Right? I think this example works. You can check it. Right? In general, A plus B whole square need not equals to A square plus 2AB plus B square. But if you take this idea, A plus B whole square You take what is a plus b whole square in general? This is nothing but a plus b into a plus b, but this is exactly equals to a square plus ab distributed to b into a, that is ba, b into b, b square. So in general, this is true. A plus b whole square is equals to a square plus ab plus ba plus b square. In general, this is true, right? But when you take actually ab, and ba, both are 0. When you take a and b, ba, both are 0. A plus b whole square is equals to a square plus b square. Yes or no? Is it clear? When you take ab, ba equals to 0 matrix, then a square plus b square is a plus b whole square is equals to a square plus b square. This is a very, very important result, right? This is very, very important result. These two results are very, very important results, right? Similarly, in general, binomial theorem need not hold for a sum of matrices. We have seen a plus b whole square need not equals to a square plus 2ab plus b square. But the thing is, whenever a and b are conformable, and you can take any positive integer, and you know that a and b are commutative with respect to matrix multiplication, this a plus b whole power n, in general this result may not be true, but when you take ab equals to ba, this result hold, right? A power n nc1, a power n minus 1 b nc2, a power n minus 2 b square, going on ncn, that means 1 b power n, right? In general this result may not true, understand, this result may not true. But the thing is that when you take a and b are commutative, when you take a and b are commutative, that means a plus b whole square is equals to a square plus b 2ab plus b square. Whenever a and b are commutative, a plus b whole square is equals to a square plus 2ab plus b square. So this is very, very important when I'm teaching, that in further classes, invertible matrices, at least one of the question will ask in CSIR, right? Suppose a and b are invertible, does it mean that a plus b is invertible, right? Right, this result, you should keep in mind these results. In general, binomial result may not hold for matrices, but binomial result hold for matrices whenever a and b are commutative. Whenever a and b are commutative, a plus b whole power n is equals to a power n nc1, a power n minus 1 b plus nc2, a power n minus 2 b square, and going on b power n. So this is very, very important, right? Next is submatrix. This is also important concept when we deal with the rank of a matrix. What is submatrix in general? Submatrix is nothing but what? It's a matrix. Suppose you are given a matrix m by n, right? So a matrix, right, obtained from a matrix for a given by a given matrix, from a given matrix by leaving 0 rows. 0 rows means what? Don't leave any row, or some rows or some columns is gone, but not all. You need to write, but not all. Right? It's called a submatrix. Of a given matrix A. Right? Suppose you can take an example. A equals to 1, 2, 3, 4, 5, 6. Right? What are the submatrix? What are the submatrix? Leaving 0 rows means what? Don't leave any row. A matrix itself is a submatrix. Don't leave any row. So what is 0 rows? 0 means what? Don't leave any row or any column. That is nothing but a matrix itself is a submatrix. Second one, suppose you leave first row. what is first row? Suppose you leave 1, 2, 3. What you're going to get? 4, 5, 6. This is submatrix. Suppose you leave second row. What is your submatrix? This also row. This also submatrix. Suppose you leave first column. Suppose you leave this first column. What you're going to get? This also submatrix. Suppose you leave second column. This is also submatrix. Suppose you leave third column. Yes or no? Suppose you leave 2 columns. Understand? Each of them is a submatrix. But the thing is, suppose you take this 1, suppose 5, 2, 6. Is it a submatrix? Is it a submatrix? No.
No.
Because, right? Now, so definition is not satisfied. If you look at 5 column is not deleted. If you look at the 5 column is not deleted. So what you observe is that in a submatrix, permutation of entries should not be allowed. So what is notice? Notice is that this is not a submatrix. Why? Because permutation of entries or arrangement of entries. Permutation of entries or arrangement of entries should not be allowed. Understand, this is important, right? Suppose you're given this question. Suppose you're given matrix like this. Is it a submatrix? Is it a submatrix? Deleting all rows, all columns. Is it a submatrix?
No, sir.
No. What I'm telling,
No,
what is my definition? But not all. Delete some row, delete some column, okay. Some columns, some rows, okay. But the thing is, not all rows, not all columns. That is important. Right? So this is not a submatrix. Right? Next is suppose you're given a matrix 1, 2, 3, 4. See, what are the submatrices generally? Generally, what are the submatrices for this matrix? This is 2 by 2 matrix. What are the possible submatrices? 1 cross 1 matrices, 1 cross 2 matrices, 2 cross 1 matrices,
2 cross
2
1.
cross 2 matrices. Yes or no? Now my question is, number of submatrix
4.
submatrix of order 1 by 1. Yeah, tell me.
2.
1 by 1 submatrices. Ennuntayamma?
1, sir.
You know, this is a
Four.
submatrix 1 by 1.
4.
This is also
No,
1 by 1,
No, sir. 0.
No, sir, 0.
right? So what is the submatrix? 1 by 1.
1
1
sir.
by 1.
1.
1 by
One.
1.
Only
sir.
1. Is it a submatrix?
Yes, sir.
No. 1 by 1. Suppose you look at this column. You look at this column is deleted, okay. But what about this? What about this? How many submatrices? Anybody? Only 1?
0. 0.
0 or 1?
0, sir.
itself అయితే
Uh-huh.
1 సార్
1 అంటే ఇదేంటి చెప్పండి, ఆ మ్యాట్రిక్స్ ఏంటి?
Every single element is also a matrix.
sir.
No, sir.
తీసుకునే ఎలిమెంట్ అదే సింగిల్ ఎలిమెంట్
1 అంటే ఆ మ్యాట్రిక్స్ ఏంటి?
ఏ మ్యాట్రిక్స్?
ఏ మ్యాట్రిక్స్ తీసుకుంటే అదే అయితే కదా సార్.
నేను ఏమంటున్నా, ఆర్డర్ 1 అంటున్నా, ఆర్డర్ 1 by 1 సబ్ మ్యాట్రిక్స్ అంటున్నా.
Order 1 by 1 not
No, sir.
exist.
No,
sir.
sir, not exist.
Definition satisfy
Yes.
కదా, sir. 1 by 1.
ఓకే
Sir, every single element is also matrix, sir.
యా, దట్స్ వాట్ మై పాయింట్ కదా. ఇది కాదా ఇప్పుడు?
Singleton set 1, 2, 3, 4 also.
యా, ఇది కాదా? ఇప్పుడు ఈ సెకండ్ 2 మ్యాట్రిక్స్ అంటే ఏంది? ఈ రో ఈ కాలం డిలీట్ చేస్తా. ఎసాను
Yes.
ఫస్ట్ కాలం, సెకండ్ రో ఇది తీసుకుంటాను. సో ఇవి ఏంటి యాక్చువల్గా? రైట్? ఇస్ ఇట్ రైట్?
Yes.
ఇది కరెక్టే కదా? ఎసాను
Correct.
ఎనీ డౌట్? 1 by 1 మ్యాట్రిక్స్ is possible, right? Right? Number of number of submatrices of order 1/2. చెప్పండమ్మా 1/2. 1 row 2 column చెప్పండి 1 row 2 column ఏమొస్తాయి
2 sir. 1, 2,
3 4 అంతే
3, 4.
అంతే ఫస్ట్ రో డిలీట్ చేయండి ఒకటి వస్తుంది సెకండ్ రో డిలీట్ చేయండి ఇంకోటి వస్తుంది దీనికంటే ఇంకెక్కువ ఉంటాయా ఛాన్సెస్
No sir.
నెంబర్ ఆఫ్ సబ్ మ్యాట్రిసెస్ ఆఫ్ ఆర్డర్ 2/1 చెప్పండి 1 కాలమే ఉండాలి 1 కాలం ఉండాలి అంటే ఏంది 1 కాలం 2 rows this one delete second row
1/3,
1, 3, 2, 4.
2/4.
2 4 next number of submatrices of order 2/2 ఇది చెప్పండి అమ్మా
1, 2, 3, 4.
1, 2, 3, 4.
Only
Itself,
one.
sir.
matrix itself
Matrices.
ఇప్పుడు చెప్పండి నోట్ టోటల్ నెంబర్ ఆఫ్ సబ్ మ్యాట్రిసెస్ అని చెప్పండి
9.
how many that 1 2 3 4
Nine,
this is
sir.
6
Nine.
8 9 ఇదే క్వశ్చన్ ఇట్లా ఇస్తాను a equals to 1 1 1 ఆల్ ఎంట్రీస్ సేమ్ అమ్మా 2/2 ఇప్పుడు చెప్పండి అమ్మా నంబర్ ఆఫ్ సబ్ మ్యాట్రిసెస్ ఆఫ్ ఆర్డర్ 1 చెప్పండి
4. 4.
4
4.
చెప్పండి
1,
1,
sir.
1, 1, 1.
is it right
Only 1, sir.
Only one.
only one that's it
Only.
ఓన్లీ 1 కదా సార్ ఓన్లీ 1 కదా 1
Yes,
అంటే
sir.
1 1 1 అంటే 1 కదా
Hmm.
1 అండర్స్టాండ్ నెంబర్ ఆఫ్ అన్నాను కదా సెట్ లో ఇంకో ఎలిమెంట్ ఇంకోసారి రాయం కదా ఇప్పుడు 1 1 1 1 అని ఇట్లా రాస్తావా కార్డినాలిటీ నేను అడుగుతున్నా కార్డినాలిటీ నంబర్ నంబర్ నంబర్
Okay, okay.
సో ఒకటే ఉంటది కాబట్టి ఇదన్నీ తీసేస్తాం సో వాట్ ఇస్ ఆన్సర్
1.
1 ఓన్లీ 1 దట్ ఈస్ 1 రైట్ నెక్స్ట్ నెంబర్ ఆఫ్ సబ్ మ్యాట్రిసెస్ ఆఫ్ ఆర్డర్ 1/2 చెప్పండి
1, 1 is
1, sir.
వాట్ ఈస్ దట్ ఓన్లీ దిస్
Oh,
only this what is that
yes,
1
sir.
number of submatrices for order 2/1 చెప్పండి 2/1 చెప్పండి ఇదే కదా
Yes, sir.
yes or no
Yes, sir.
so this is my set so this is 1 similar number of submatrices of order 2/2
Itself.
itself అంటే no same 1 what is the set what is that
4.
1, 1, 1.
what is that this is 1 this is 1 1 1 1 right so did you understand the difference between these two problems ఇక్కడ ఏం అబ్జర్వ్ చేశారు చెప్పండి if the elements are distinct if the elements are distinct all the elements are distinct we can have something if the elements are all elements are identical right
Then
so the formula is different right the argument is different right yes or no so what is that
Yes, sir.
actually here is notice suppose నేను so suppose ఇదే ప్రాబ్లం ఇచ్చాను 1 2 3 4 number of submatrices is there any formula for that of order 1 1 1/1 is there any formula see actually I need actually 1 row 1 column but you know actually how many rows how many columns you know how many rows how many columns I is running from 1 to 2 how many columns j running from 1 to 2 but what I require is that I require only 1 column 1 row so your total number of rows 2 total number of columns 2 I require actually only 1 row 1 column so I need to pick 1 row from 2 columns to see one but submatrices is not completed because actually I need what 1 row 1 column 1 row one column. So you need to pick one column from two rows, two columns. So therefore 2 into 2, that is means essentially 4. Similarly, number of submatrices of order 1 by 2. How many rows do I need? One row from two rows. 2C1. How many rows? How many columns do I need? Two columns from two columns. 2C2. So that means 2C1 into 1. This is equals to 2. Right. Next, number of submatrices of order 2 by 1. What is it? I require two rows from two rows. 2C2. One column from two columns. 2. Right. Similarly, number of submatrices of order 2 by 2, that is 2C2 into 2C2, that is 1 into 1, that is 1. Is it clear? So what is the formula you are getting actually here is, if the all elements, suppose A is what actually A is suppose M by N matrices, right? This is my notes, right? Suppose number of you need to write like this, number of submatrices of order P cross Q is, first one is MCP into NCQ if all elements are distinct. If all elements are distinct. Right? Second one, if all elements are equal, means identical. What you're going to get? For each order, you're going to get only one matrix. P cross Q order ఎన్ని ఉంటాయమ్మా? Identical అయినప్పుడు ఒకటే ఉంటుంది కదా? Is it no? Is it clear? Is it only one? Is it clear? See, అన్ని ఐడెంటికల్ ఉన్నాయి అనుకోండి. ఫర్ ఎగ్జాంపుల్ ఏ M by N మ్యాట్రిక్స్ ఏ ఇట్లాంటి ఎన్ని ఉంటాయి చెప్పండి? ఒకటే ఉంటుంది కదా. అన్ని ఐడెంటికల్ అయినప్పుడు ఏముంటుంది? ఓన్లీ వన్. ఎస్ నో?
Yes, sir.
Is it clear? ఇక్కడ ఇంతకుముందు చేసాం కదా. సి నాకు 1 cross 1 కావాలి. ఎన్ని ఉన్నాయి చెప్పండి ఇక్కడ? ఒకటే ఉంది. 2 cross 2 కావాలి. ఎన్ని ఉన్నాయి? ఒకటే ఉన్నాయి. 1 by 2 కావాలి. ఎన్ని ఉన్నాయి? ఒకటే ఉన్నాయి. 2 by 1 కావాలి. ఎన్ని ఉన్నాయి? ఒకటే ఉంది. సో ఎప్పుడైనా ఐడెంటికల్ ఉన్నప్పుడు యాక్చువల్గా వాట్ ఈస్ ద ఫార్ములా? యూనిక్. ఒక్క ఆర్డర్కి ఒకటే ఎలిమెంట్ ఉంటుంది. ఒక ఆర్డర్కి ఒకటే మ్యాట్రిక్స్ వస్తుంది. ఒకటే సబ్ మ్యాట్రిక్స్ వస్తుంది. ఇస్ ఇట్ క్లియర్? హలో.
Okay, sir.
Okay.
Yes.
Right. This is my first notice. Right. Suppose A is a M by N matrices. Right. Number of submatrices should be bounded by M into N number of submatrices. All number of submatrices. Number of submatrices. All number of 1 cross 1, 2 cross 1, 3 cross 2. All submatrices is bounded below by Mn and bounded above by 2 power M minus 1 into 2 power N minus 1. Is it right or not? Yes or no? Why? Because what is this actually? This is nothing but what actually if the matrix all elements are equal, understand, if all elements are equal, suppose if all elements are need to write like this. If all elements are equal, all elements of a matrix are equal, what is the submatrix? Anybody? 1 by 1 submatrix any unte cheppandi? Only one. 1 by 2 only one. 1 by 3 only one. N by 1 only one. 2 by 1 only one. 2 by 2 only one. Yes or no? So 2 by N
Only one.
only one. m by 1
Only one.
only 1, m by 2 only 1,
Only one.
similarly m by n only 1.
Only
ఇప్పుడు
one.
టోటల్ ఎన్ని ఉంటాయి?
N.
mn ఇక్కడ దాకా n,
Oh, sorry.
each వాటికి n, this is n, this is n, this is n, total n plus n plus n plus n plus n, mn. Is it clear? So if the all elements are equal, total number of submatrices are nothing but total number, all orders, ఇవి all orders అమ్మా. mn అంటే ఏంటి? all orders, 1 by 1, 2 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by n, 2 by 1, 2 by 2, 2 by 3, 2 by 4, 2 by 5, 2 by n. Similarly m by n, m by 2, m by 3, m by 4, m by 5, m by n. So if the all entries are equal, what is the formula for that submatrices? Total number of submatrices is nothing but mn. Suppose if all elements are distinct, you know, actually, suppose I need a p by q matrix. What is number of submatrices of order p by q? You know,
NCP into
MCP.
NCQ.
Yeah, good.
NCP.
MCP into NCQ.
MC.
But what I require actually, p should be vary, right? Because I need to find number of total submatrices. I need to find total submatrices. So p should be vary from p equals to 1 to p equals to m, because p is a row. P stands for row, q stands for column. Therefore, p running from 1 to m, q running from 1 to m. I need to find total number. So number of submatrices of A is nothing but total equals to 1 to m, q equals to 1 to m, MCP, MCQ. That means the summation p equals to 1 to m, MCP into summation n equals to 1 to n, p equals to 1 to n, NCQ. But this is nothing but what actually, you know, in binomial expansion, MC1 plus MC2 plus MCM, MC0 is nothing but 2 power m, right? But what I require is MC1 plus MC2 plus MCM, that is nothing but what? 2 power m minus 1. This is nothing but what? 2 power m minus 1 into 2 power n minus 1, right? So if all elements are distinct, total number of submatrices is nothing but actually is 2 power m minus 1 into 2 power n minus 1. If the all elements are equal, that is nothing but mn. Therefore, total number of submatrices which are bounded below by mn, total number of submatrices of A. See, there is no restriction of order. All submatrices which are bounded by this one. So this is very, very important. Is it clear? Suppose you are given a question. Suppose your matrix is A equals to Aij, right? Number of submatrices Aij of order 6 by 7. Number of submatrices of order 3 by 4 of A lies between option A 1 to 800, option B 42 to 900, option C 1 to 700, option 4 12 to 42. Tell me. Number of submatrices of order 3 by 4. What I require అమ్మా 3 by 4 కావాలి. See, ఇక్కడ కావాల్సింది ఏంటి చెప్పండి? 3 by 4 కావాలి. ఇక్కడ రెండే ఆప్షన్స్. Look at the lower bound, look at the upper bound. Look at the lower bound, look at the upper bound. Right? So
105.
Sir,
yeah,
option
tell me.
2
Four,
or
four.
4,
Five.
sir. 2 or
Option?
4.
2.
4 ah?
4.
Okay, look at answer.
2,
Oh,
2,
okay.
sir.
I'll see what is the answer. See, there are two possibilities. I already told you. So if all elements of A are equal, what is the matrix actually? 6/7 matrix. Yes or no? 6/7 matrix. Yeah, tell me now what I require. ఇప్పుడు చెప్పండి ఇది 6/7 3/4. 3/4 ఎన్ని ఉంటాయి చెప్పండి? Number of submatrices, in this case, number of submatrices of order 3/4. ఇప్పుడు ఎన్ని ఉంటాయి చెప్పండి? ఇంతకుముందు చెప్పాను మీకు, యూనిక్ ఉన్నప్పుడు ఏమైంది, అన్ని సేమ్ ఉన్నప్పుడు ఏమైంది ఆర్డర్తోని? ఎన్ని వస్తాయి సబ్మాట్రిసెస్?
1 sir.
ఓన్లీ వన్. ఒకవేళ అన్ని ఎలిమెంట్స్ డిస్టింక్ట్ ఉన్నాయి అనుకోండి, ఆల్ ఎలిమెంట్స్ ఆఫ్ ఏ ఆర్ డిస్టింక్ట్, అన్ని డిస్టింక్ట్. ఇప్పుడు చెప్పండి అమ్మా, నెంబర్ ఆఫ్ సబ్మాట్రిస్.
NCP into NCQ.
Yeah, good.
Okay,
That's it. Number of submatrices of order 3/4 is nothing but, యాక్చువల్లీ మనకు రోస్ ఎన్ని ఉన్నాయి? 6 ఉన్నాయి. 6 లో మనకు కావాల్సిన 3A. సో 6 3. ఇక్కడ టోటల్ రోస్ ఎన్ని ఉన్నాయి? 7 ఉన్నాయి. మనకు కావాల్సిన 4 కాలమ్స్ ఏ. సో 7C4.
7C4.
సో 6 into ఇంత ఆన్సర్ 4 divided by 6 7 6 5 4 by 4 3 2 1, right? So 6 cancel. At here 6 cancel. 4 cancel. Okay, what is that?
30,
20 into 35.
20 into 30.
20 into
30.
30 or 35?
600. 7 plus. Okay, sir. 35.
35 sir.
35, sir.
Yeah, 35 into 20.
35 2 just 700.
700. So minimum bound is 1, maximum bound is 700. So what is the answer?
9. Second one sir.
No, third one 700.
Third.
This is 700, no? This is 700. Right? So this is the answer. Is it clear? Hello? Is it clear, Amma?
Yes, sir.
Yeah, tell
Yes, sir.
me. Tell me. Doubt? Hello? What are your doubts? Okay. Suppose, second question. Suppose A is a matrix, Aj of order 6/7, right? In which each entry is equals to 1, right? Then number of submatrices of A in which at least 3 rows, right? Option A 42, option B 21, option C 28, option D 18. Number of submatrices of A with at least 3 rows. Tell me, Amma. So what is your matrix you are given? You are given a matrix of 6/7. 6/7. Each entry is 1. Each entry is 1. See, first look at the question carefully. What is the matrix? 6/7 matrix, right? In which each entry is 1. Then you can have some idea about the problem. Six by 7, right? Right? This is 6/7. Now tell me, number of submatrices of A with at least 3 rows anta. Mana 3 rows ఉన్నాయి కావాలమ్మా, చెప్పండి. రోస్ కాలమ్స్. మనకు కావాల్సిన ఏంటి? మినిమం 3 rows ఉండాలి కదా. I stands for rows, J stands for column. సో మినిమం 3 rows ఉండాలి కాబట్టి 3 తో స్టార్ట్ చేయండి. కాలమ్స్ ఎన్ని అయినా ఉండొచ్చు. J ఈక్వల్స్ టు 1 కావచ్చు, 1 కావచ్చు, 2 కావచ్చు, 3 కావచ్చు, 4 కావచ్చు, 5 కావచ్చు, 6 కావచ్చు, 7 కావచ్చు. మినిమం 3 rows కాబట్టి I ఈక్వల్స్ టు 4, 1 కావచ్చు. కాలమ్స్ మే బి ఎనీథింగ్. rows row equals to 5. Column may be 1 row, 2 row, 3 row, column 3 column, 4 column, 5th column, 6th column, 7th column. How many rows you have? 6 rows for a matrix A. So column may be 1, 2, 3, 4, 5, 6. Now tell me, what is the number of submatrices whose row is actually with 3 row and 1 column? Tell me, Amma. Number of submatrices of 3 row 1 column. ఎన్ని ఉంటాయి చెప్పండి?
1 sir.
Only 1. Number of submatrices of 3 row 2 column. ఎన్ని ఉంటాయి చెప్పండి?
1.
Only 1. Right? How many total ఎన్ని ఉంటాయి చెప్పండి ఇప్పుడు?
7.
7 sir.
Total what is that?
7.
7. Total is 7. Similarly here, number of
It is also
submatrices.
7.
Number
It
of
is also
submatrices. This is also 7. Number of submatrices of order 4 by 1. ఎన్ని ఉంటాయి? Only 1.
7.
Only 1. Similarly, number of submatrices of order 4 by 2. ఎన్ని ఉంటాయి? Only 1.
It is also
So up to only 7. So this is also 7. This is also 7. Total is 20. Is it clear? So what is the answer?
28 sir.
28 is the answer. So look at the question carefully, then go through the problem. Right? Next, ఇదే క్వశ్చన్ నెంబర్ ఆఫ్ సబ్ మ్యాట్రిసెస్ విత్ ఎట్మోస్ట్ 3 rows అంటే ఏం చేస్తారమ్మా? ఎట్మోస్ట్ 3 rows అని అడుగుతాను. ఏం చేస్తారు?
4 నుండి చేయాలి సార్.
యా దట్స్ ఇట్. ఎట్మోస్ట్ 3 rows. No, ఎట్మోస్ట్ 3 rows. 3 rows ఏ
1,
ఉండాలి.
2, 3 only.
3 వరకే. 1, 2, 3.
సో 1 row కావచ్చు, కాలం ఏమైనా కావచ్చు. 1, 2, 3, 4, 5, 6, 7. ఎట్మోస్ట్ 3.
Only 7.
One, 2, 3, 4, 5, 6, 7. ఇంతకంటే ఎక్కువ తీసుకుంటారు ఇంకా 3 ఎట్మోస్ట్ 3 అంతకంటే ఎక్కువ ఉండదు కదా. టోటల్ ఎన్ని ఉంటాయమ్మా?
21.
సో వాట్ ఇస్ ఆన్సర్?
21 sir.
సో నెంబర్ ఆఫ్ సబ్ మ్యాట్రిసెస్ of A with at most just wait. So therefore number of submatrices at most 3 rows is 21. Right? This is what actually answer. Next is number of my question number of submatrices of order of a matrix of order 3 by 4 cannot exceed option A 100, option B 105, option C 210, option D 171. So matrix order ఏమి ఇచ్చాడు? Look at a matrix order. What is the matrix order?
3 by 4.
3 by 4. I need to find the number of submatrices of order, number of submatrices of A which cannot exceed which number? Number of
105
submatrices.
sir.
Is only one possibility?
105.
Okay, is it only one possibility?
Yes sir.
Is it only one possibility? See, look at the upper bound. That is at most, right? At most, right? Cannot exceed. When do you say that actually that submatrices are maximum? when the elements are distinct, when the elements are distinct, you are going to get a maximum upper bound. Yes or no? You're going to get a max upper bound. So look, find out the upper bound, right? Find out the upper bound. What is upper bound formula? Here m equals to 3, n equals to 4. When the entries are distinct, you're going to get a big number of submatrices, right? So total number of submatrices, what is that? You know, what is that? Total number of submatrices?
2 power m minus
Submatrices.
1.
Yeah, submatrices of A. If
Equal-
all elements are distinct,
2 power m minus 1 into
2
2
power 3
m
minus 1 into 2 power 4 minus 1. That means what? 7 into, what is that? 15. What is that? 105. Question is that actually, is it option right? Is it option right? 100. Is it right? No, right? Because 105 is exceeding actually 100. So this option is not right. What is actual question? Number of submatrices of matrix A cannot exceed. But what happens? 105 exceeds 100. Therefore, this is not our option. Yes or no? So here 105 cannot exceed 105. Yes or no? So this answer is right. Understand? This 105 cannot exceed 200, 210. So this answer is also right. Here 105 cannot exceed 175. This also answer right. So what are the answers? 105, 210, 170. Is it clear? See, exceed అన్నాడు కాబట్టి దానికంటే ఎక్సీడ్ అంటే దానికంటే ఎక్కువ ఉండదని మనం ఫైండ్ అవుట్ చేయాలి. అంటే అప్పర్ బౌండ్ ఫైండ్ అవుట్ చేయాలి. కెనాట్ ఎక్సీడ్ అంటే అది ఫైండ్ అవుట్ చేయండి. ఒకవేళ కెనాట్ లెస్ దెన్ అంటే ఏం చేస్తారు? నెంబర్ ఆఫ్ సబ్ మ్యాట్రిసెస్ ఆఫ్ ఆర్డర్ 3/4 కెనాట్ బి లెస్ దెన్ అంటే ఏం చేస్తారమ్మా? లుక్ ఎట్ ద లోవర్ బౌండ్. Look at the lower bound. What is the formula for lower bound? Amen. What is the formula for lower bound? What is the formula for lower bound? Amen. Less than దీనికంటే తక్కువ ఉండదు అంటే లోవర్ బౌండ్ కనుక్కోండి. ఎక్కువ ఉండదు అంటే అప్పర్ బౌండ్ కనుక్కోండి. దట్స్ ఇట్. ఎక్కువ ఉండదు అంటే ఎప్పుడు ఎక్కువ ఉంటాయి చెప్పండి? ఎప్పుడు ఎక్కువ ఉంటాయి? ఎంట్రీస్ డిస్టింక్ట్ ఉన్నప్పుడే కదా. అర్థమవుతుందా? సబ్ మ్యాట్రిసెస్ ఎప్పుడు ఎక్కువ ఉంటాయి? ఇన్ని ప్రాబ్లమ్స్ లో చేసిరు కదా. సబ్ మ్యాట్రిసెస్ ఎప్పుడు ఎక్కువ ఉంటాయి? ఎప్పుడు ఎక్కువ ఉంటాయి? ఎంట్రీస్ డిస్టింక్ట్ ఉన్నప్పుడే కదా. ఎంట్రీస్ ఈక్వల్ అయినప్పుడు ఏమవుతుంది? యూనిక్ వస్తుంది కదా. ఒక్కొక్క ఆర్డర్కి ఒక్కొక్కటి వస్తుంది కదా. ఎస్ ఆర్ నో? ఇస్ ఇట్ రైట్? హలో, ఎంట్రీస్ అన్ని ఈక్వల్ ఉన్నాయి అనుకోండి. ఫర్ ఎగ్జాంపుల్ 1x1 మ్యాట్రిక్స్ కావాలి, ఎన్ని వస్తాయి? 1 వస్తుంది. 1x2 రావాలి, ఎన్ని వస్తాయి? 1 వస్తుంది. ఎంట్రీస్ ఈక్వల్ అయినప్పుడు లోవర్ బౌండ్ వస్తుంది. ఎంట్రీస్ డిస్టింక్ట్ ఉన్నప్పుడు అప్పర్ బౌండ్ వస్తుంది. మనం ఇక్కడ కావాల్సింది కెనాట్ ఎక్సీడ్ అన్నాడు, రైట్? దానికంటే ఎక్కువ ఉండొద్దంట. సో దర్ఫోర్ యూ నీడ్ టు ఫైండ్ అన్ అప్పర్ బౌండ్ ఫర్ ద నెంబర్ ఆఫ్ total number of submatrices of order 3/4. That's it. Next is principal submatrix. Principal submatrix means it is a square submatrix. You take a square matrix first of all. Square matrix. Because principal is possible for only square matrix. So a square matrix, a square submatrix of a given matrix A is principal submatrix of a matrix A if and only if its diagonal entries are precisely the diagonal elements of a given matrix. Diagonal elements of a given matrix A. Understand? The entries of the diagonal should be the entries of the diagonal of a given matrix. Suppose you take a square matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Suppose what is the principal submatrix? Delete. Suppose you can take this 1, 2, 4, 5. Is it a principal submatrix? Yes. Because the diagonal entries, what are the diagonal entries of this? 1, 5. What are the diagonal entries of given matrix? 1, 5, 9. So the diagonal entries of a submatrix are precisely same as saying that the diagonal entries of the given matrix. If that happens, that matrix is a submatrix, principal submatrix. Suppose you can take 2. Example 2. Suppose you can take this 5, 6, 8, 9. What are the diagonal entries? What are the diagonal entries? 5, 9. Yes or no? Therefore, it is a principal submatrix. Suppose you can take this. Suppose you can take this 1, 3, 7, 9. Is it principal submatrix? Yes, because the diagonal entries are precisely the diagonal entries of the given matrix. Is it principal? Suppose you can take this 1, 1, 3, 4, 6. Is it principal submatrix? Is it submatrix first of all? Is it submatrix? Yes. Is it submatrix? Yes, because you know what is a matrix? 1, 2, 3, 4,
Yeah.
5, 6, 7, 8, 9. Yes or no? Is it
Yes.
submatrix? Yes. So deleting this column, deleting this row, you know, you're going to get a submatrix. Yes or no? Question is it principal? Is it principal?
No.
No, because the diagonal elements appearing here are different from the diagonal elements of the given matrix A. So it's not principal. Is it clear? Next, suppose you take this 1, 2, 4, 5. Is it actually principal submatrix?
Yes,
Is
sir.
it first of all submatrix? Is it submatrix?
Sir.
Is it submatrix?
No, sir.
No, right? Why? Because already what I told you is that permutation of entries should not be allowed. What happened here? What is 1, 2 entry is 2. What is 1, 2 entry here? What is 1, 2 entry? Is a 2, 1 entry here. Here, what is 1, 2 entry? 2. Right? So what is 1, 2 entry here? 2. What is 2, 1 entry? 2. So therefore the permutation is allowed, right? For this example, therefore it is not a submatrix. What I told you is that whenever I talk about submatrix of a given matrix, the entries of a given matrix should not be permutated. Should not be permutated. But what happens in this case? You know, the entries are permutated. Therefore, it's not a submatrix, in fact. So not submatrix means what? Not principal. Is it clear? Now my question is that how many submatrices? How many submatrices? How many 1 by 1 submatrices? Anybody? Number of, for this problem, number of 1 by 1 submatrices. Tell me, Amma.
Singleton.
Singleton 1. Next.
Singleton
Next.
4.
Singleton 5. No, not 4, because it should be diagonal, right?
9, sir.
9.
3.
So what is that? How many?
Total 3.
Total 3. So number of 2 by 2. Is there any 1 by 2 matrices? Principal submatrices? Is there any 1 by 2 submatrices? No, right? Principal means it should be square. It should be square. Understand? It should be square. There is no 1 by 2 principal submatrices, because according to the definition, when you want to talk about principal, it should be square submatrix. It should be square submatrix. So there is no 2 by 1 submatrix. So the only thing is number of 2 by 2 principal submatrices. Principal submatrices. Tell me, Amma, what is it? Your matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9. Tell me now. What are
1, 2,
submatrices? Tell
1,
me.
2, 4, 5.
1, 2, 4, 5. Next.
5, 6, 8, 9.
5, 6, 8, 9.
1, 2, 8, 9.
1, 2, 8, 9. No, right? 1, 3, 7, 9. Understand? Delete.
Okay.
See, what is the trick behind this is, when you want to talk about a principal submatrix, delete the same number of rows, same number of column.
Okay.
Understand? Delete first row, first column. You get 5, 6, 8, 9. Delete second row, second column. You get 1, 3, 7, 9. Delete third row, third column. You're going to get 1, 2, 4, 5. When you want to talk about principal submatrices, delete the same number of row with the same number of column. Understand? Delete first row, first column. You're going to get principal submatrix. Delete second row, second column. You're going to get principal submatrix. Delete the third row, third column. You're going to get another principal submatrix. So how many?
3.
How many? 3. Next, number of 3 by 3 principal submatrix. How many?
Itself.
Only one itself. Only one. Yes or no? Only one. Right? Now tell me, is there any formula for that? Is there any formula for that? Suppose you're going to give a question like this. Suppose your matrix is 1, 1, 1, 1, 1. If the all entries are same. Question is number of 1 by 1 submatrices. Tell me. Yeah.
Only one.
Only one, right?
One.
Only one, right? Number of submatrices. Principal submatrices. Of 1 by 1 order is only one. Similarly, number of principal submatrices of order 2 by 2.
Only one.
Only one. It is only one. Similar number of submatrices of 3 by 3
That is also only one itself.
itself. Now my question, is there any formula for that? Can you generalize it? The answer yes. So total number of submatrices, principal submatrices, in this case 3. In this case, what is total? What is total? 6, 7. What is that? 7. Is there any formula? Can you generalize it? Yeah, generally we can generalize it. Sir, Nagesh sir?
Sir.
Yeah. Shall I
Okay,
start?
sir. Continue, sir. Continue,
Yeah.
sir. No problem.
Sir is there?
No, sir. Continue. You continue up to right up.
Number of note. Number of, suppose you are given a square matrix. Of order n by n. Right? Suppose you are given a matrix of n by n. Number of principal submatrices. Number of principal submatrices. Submatrices should be bounded by 2 power m minus 1, 2 power n minus 1. Bounded below by, what is that bounded below? En. This is a very, very important formula. Why you are getting? If the all elements are equal, you are going to get n, right? 1 plus 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 1. How many get? N. Yes or no? 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus. What is this? What is this? This stands for actually what? 1 plus 1 plus 1 plus 1 plus how many rows? N rows. Therefore n. What is this actually? Look at this. Look at the distinct case. Number of 1 cross 1 submatrices is nothing but what? You need to select how many diagonal elements? How many diagonal elements? 3 diagonal elements. You need to select 1. So therefore, this is nothing but what? 3C1. That is 3. Understand? So number of submatrices of order 2 cross 2. Principal submatrix of order 2 cross 2 means what? I need to select 3C2 because I require only two entries among all diagonal entries. How many total? 3. I require only 2. Therefore 3C2. Next, number of principal submatrices of order 3 by 3 is nothing but what? You need to select all 3C3. 3C3. Therefore, total is nothing but 3C1 plus 3C2 plus 3C3 plus going on like that. So what is this actually? NC1 plus NC2 plus NC3 going on NCN. It's precisely 2 power n minus 1. Is it clear? Hello? Is it clear?
Yes.
Yes. Right? Now look at the problem. Right? Suppose problem number 1. Suppose A is equal to a matrix of order 10 by 10. Question is number of principal submatrices. Principal submatrices of order 5 by 5. Tell me order 5 by 5. Yes or no? See, actually ga meeku emunnayamma 10 by 10 submatrix undi. Yes or no? Is it clear? మరి మనకు కావాల్సింది ఏంటి 5 by 5. ఇంతకుముందు చెప్పాను మీకు మనకు కావాల్సింది ఏంటి 5 by 5 కావాలి. 5 by 5 కావాలంటే ఈ మ్యాట్రిక్స్ లో అన్ని సేమ్ ఉన్నాయి అనుకోండి, ఆల్ ఎంట్రీస్ సేమ్ ఉన్నాయి అనుకోండి, ఫస్ట్ కేస్, దిస్ మై ఫస్ట్ కేస్, ఆల్ ఎంట్రీస్ 5 సేమ్ ఉన్నాయి అనుకోండి, ఎన్ని ఉంటాయండి? 5/5 ఎన్ని ఉంటాయి చెప్పండి? ఈ మ్యాట్రిక్స్ లో 5/5 మ్యాట్రిక్స్ ఎన్ని ఉంటాయి?
1.
ఓన్లీ 1 is less than or equals to number of submatrices, principal submatrices. Um, 5/5. ఇప్పుడు చెప్పండి, దిస్ ఇస్ లెస్ దెన్ ఆర్ ఈక్వల్స్ టు వాట్ ఇస్ అప్పర్ బౌండ్? డిస్టింక్ట్ ఉన్నాయి అనుకోండి, ఏమైంది? డిస్టింక్ట్ ఉన్నాయి, ఇవన్నీ డిస్టింక్ట్. ఫర్ ఎగ్జాంపుల్ ఆల్ డిస్టింక్ట్, ఆల్ ఆర్ డిస్టింక్ట్. దిస్ 10/10 matrix, all are distinct. What I require only 5/5 amma, or what I require only 5/5. But what you have actually 10/10. What I require is 5/5. Tell me what is upper bound? I need to select only 5/5, right? I need to select only 5 rows, 5 columns above, 10 rows, 10 columns. 10C5, 10C5. Is it clear? Not like this, only 10C5, that's it. Because we need to select only 10 among 10 rows and among 10 diagonal elements, you need to select only 5. Among 10 diagonal elements, you need to select only 5 elements. Therefore, that is nothing but what? 10C5. So therefore, number of principal submatrices of order 5/5 should be bounded by 1 and 10C5. 1 and 10C5. Is it clear? సో మనం జనరల్ గా ప్రిన్సిపల్ అంటేనో జనరల్ గా ఏం చేస్తాం, మంచిగా జనరల్ గా ప్రిన్సిపల్ కాకపోతే ఏం చేస్తాం అంటే కాలం కూడా తీసుకుంటాం. ఇక్కడ కాలం అవసరం లేదు, ఎందుకంటే డయాగనల్ ఎలిమెంట్సే ఎనఫ్. మనం డయాగనల్ ఎలిమెంట్స్ తోనే పనిచేస్తాం ప్రిన్సిపల్ కి. సో ఇందులో ఎన్ని ఉన్నాయి? యాక్చువల్ గా 10 ఎలిమెంట్స్ ఉన్నాయి. ఎన్ని ఉన్నాయి? యాక్చువల్ గా 10 ఎలిమెంట్స్ ఉన్నాయి డయాగనల్ లో. బట్ మనకు కావాల్సింది ఏంటి? 5/5 కావాలి. 10 ఎలిమెంట్స్ నుంచి 5 ఎట్లా చూస్ చేయాలి? 10C5. దట్స్ ఇట్. ఇస్ ఇట్ క్లియర్? ఒకవేళ ఇక్కడ ప్రిన్సిపల్ తీసేసినాం అనుకోండి, ఇక్కడ నేను ప్రిన్సిపల్ తీసేసిన అనుకోండి, ఆన్సర్ ఏమైతే చెప్పండి? ఎనీబడి? వాట్ ఈస్ ఆన్సర్? 10C5 into 10C5. Is it clear? 10C5 into 10C5. Is it clear? అర్థమైందా? డిఫరెన్స్ అర్థమైందా అండి? వన్స్ యూ అండర్స్టాండ్ ద డిఫరెన్స్, ప్రిన్సిపల్ ఉంటే ఒక రకంగా ఉంటుంది, ప్రిన్సిపల్ లేకపోతే ఒక రకంగా ఉంటుంది. ప్రిన్సిపల్ ఉంటే మాత్రం డయాగనల్ ఎలిమెంట్స్ తోనే వర్క్ చేయాలి. ప్రిన్సిపల్ లేకపోతే మాత్రం కాలమ్స్ తో కూడా వర్క్ చేయాల్సి వస్తుంది, రోస్ కాలమ్స్. ఓకే, సపోజ్ యు ఆర్ గివెన్ ఏ క్వశ్చన్ లైక్ దిస్. Suppose A is a matrix AJ of 5/5. Number of submatrices, principal submatrices of order at least 3, at least 3/3. ఇప్పుడు చెప్పండి, at least 3/3 చెప్పండి. What is answer? At least 3/3. ప్రిన్సిపల్ సబ్ మ్యాట్రిసెస్ అంటే యాక్చువల్గా ఏముండాలి చెప్పండి? జనరల్ ప్రిన్సిపల్ సబ్ మ్యాట్రిసెస్ అంటే ఏమేమి కావచ్చు చెప్పండి? మన మ్యాట్రిక్స్ ఏంటి యాక్చువల్గా? 5/5. ప్రిన్సిపల్ సబ్ మ్యాట్రిక్స్ ఏం కావచ్చు చెప్పండి? ఆర్డర్ 1/1, 2/2.
1/2, 1/3, 1/4.
No, not like that. It should be square, right? It should be square. 3/3,
3/3, 4/4, 5/5.
5/5. ప్రిన్సిపల్ అంటే 1/1, 2/2, 3/3, 4/4, 5/5. బట్ నాకు కావాల్సింది ఏంటి? అట్లీస్ట్ 3 అంట. అట్లీస్ట్ 3 ఆర్డర్
3/3, 4/4, 5/5 కావాలి.
సో డోంట్ రిక్వైర్ దిస్, డిలీట్ దిస్ వన్. వాట్ ఐ రిక్వైర్? ఓన్లీ దిస్ వన్. ఇప్పుడు చెప్పండి అమ్మా, మ్యాట్రిక్స్ ఇప్పుడు మళ్ళీ 2 కేసెస్ తీసుకోండి. మ్యాట్రిక్స్ 5/5 కదా, అన్ని సేమ్ ఉన్నాయి అనుకోండి, ఆల్ ఆర్ సేమ్. ఆల్ సేమ్ ఉంటే 3/3 ఎన్ని ఉంటాయి చెప్పండి?
1 sir.
1. 4/4 ఎన్ని ఉంటాయి? ప్లస్
1.
1. 5/5
1.
doesn't are equals to number of principal submatrices of A with at least 3 rows. ఇప్పుడు ఆల్ డిస్టింక్ట్ ఉంటే ఏంటి చెప్పండి?
5C3,
టెల్ మీ. డిస్టింక్ట్ ఉంటే
5C3,
5C3 sir.
5C
3.
only 5C3, only 5C3, only 3. Only 3, 5, 5 what is that?
5C4,
3 by 3 you can
5C,
say.
5C4
plus 5C4
5C4 plus
plus 5C5.
5C5.
5C, that's it. So good. So what is the answer? This is 3. 5C3 plus 5C4 plus 5C5. Is it clear? So 3 rows, so 3 by 3 వస్తుంది, 4 by 4 వస్తుంది, 5 by 5 కాబట్టి 5 rows ఉన్నాయి కాబట్టి 5 నుంచి 3 సెలెక్ట్ చేయండి. 5 diagonal elements ఉన్నాయి కాబట్టి 5 diagonal elements ఉన్నాయి కాబట్టి 5 నుంచి 3 సెలెక్ట్ చేయండి. అప్పుడు ఏమొస్తుంది మీకు 3 by 3 మ్యాట్రిక్స్ వస్తుంది. నెక్స్ట్ సిమిలర్లీ 4 by 4 కూడా కావాలి కాబట్టి 5 rows 5 diagonal elements కాబట్టి 5C4. Similarly 5C4. That's it. Is it clear? Next is what you have seen is the diagonal element, diagonal line. You have seen diagonal line. What is the diagonal line? Suppose you are given a n by n matrices, pure matrix. One n minus 1, A21, A22, A23, A2, 2n minus 1, A2n, next A31, A32, A33, A3n minus 1, A3n. Next a n minus 1, 1, a n minus 2, 1, 2, a n minus 1, 3, a n minus 1, n minus 1, a n minus 1, n. Next a n 1, a n 2, a n 3, a n n minus 1, a n n. This is my n by n matrix. You know what is the principal diagonal? Any line along these diagonal elements. This is principal diagonal. What is this? Principal diagonal. So what I require is a super diagonal. What I require? Super diagonal line. Super means at least one is bigger, right? One is bigger. So this is my super diagonal. What is that? This is my super. What is this? Super diagonal line. What are the entries? Anybody? Can you tell me? See this A12, A23 like this. That means what you observe is any entry should be of the form AJ. Here second index is big, just one bigger than your row index. That means J equals to I plus 1, J equals to I plus 1, where I is running from first row, second row, third row, fourth row, n minus 1 row. Is it right? So these are nothing but super diagonal elements. Is it clear? Hello? Is it clear? Yes. Next, super diagonal. That means, you know, this is my super. This is, what is this? This is my super diagonal. Yeah, tell me. Tell me, see, what is the form of this AJ, where second second index is bigger than your row index by 2. That means J equals to I plus 2, where I is equals to first row, second row, third row, fourth row, up to n minus 2 row. These are the super diagonal elements. Similarly, subdiagonal elements. Tell me subdiagonal. Subdiagonal. Tell me the subdiagonal. What is subdiagonal? Anybody? This one. This one. Oh, sorry. This is my subdiagonal. Yeah, what are the form of this? What are the form of elements? AJ, where your first index is bigger than your second index by 1. That means AJ, where I is equals to J plus 1, where J is running from first column, second column, third column, fourth column, n minus 1th column. Right? Next, what is the subdiagonal? Line. What is subdiagonal? Similarly, Aij such that this is subdiagonal. What is subdiagonal? What is this actually? Anybody? What is this? This is an minus an minus 2. Tell me. This is nothing but what? Subdiagonal. At what are the entries? I plus I equals to I equals to J plus 2. J plus 2. Right? So where J equals to running from 1, 2, 3 up to n minus 2. Right? These are subdiagonals. Next is, next question is, suppose your matrix is this. It's a square matrix. A11, A12, A13, A1, n minus 1, A1n, A21, A22, A23, next A2n minus 1, A2n, next A31, A32, A33, A3n minus 1, A3n, next is AN1, AN2, AN3, AN minus 1, ANN. Yeah. Now question is, this is what is question is number of elements whose sum of the suffixes is 2. Number of elements in A whose sum is actually what? Whose sum of the suffixes? Whose sum of the suffixes is 2. I plus j is 2. Look at the sum. What is I plus j? What is I plus j? I plus j equals to here 2, right? 1 plus 1 equals to 2. So I plus j equals to 2 means what? How many elements? Only A11. Yes or no? Only one entry, number of elements. What is the number of elements whose suffixes sum is 2? What? How many number of elements whose sum of suffixes is 2? Only one entry, A1 one entry. Yes or no? Right? Similarly, number of elements whose sum of suffixes is 3. How many? How many?
2, sir.
2. Next, number of suffixes, number of elements whose suffixes is 4. 3. Going on. Number of elements whose sum of suffixes is n plus 1. Whose sum of suffixes is n plus 1.
N.
Next, number of elements whose sum of suffixes is n plus 2.
N minus 1. N plus 1.
No, n minus 1 only, right? This is 2n to going on like this. Downward. 2n to downward. That means what? Only one element is missing. What is one element? It's called one element is missing. From here to here, only n minus 1 elements. Next, n plus 3. N minus 2. Right? Going on. Total 2n. What is 2n? Only 1. Right, this is nothing but this is also important. Number of elements whose sum of suffixes is 2, number of elements whose sum of suffixes is 3, number of elements whose sum of suffixes is 4, like that going on, right? So this is also important idea, right? Next is conjugate of a matrix. So what is conjugate of a matrix? You start with any m by n matrix. Conjugate of a matrix is denoted by a bar, whose entry, ijth entry, is simply obtained by conjugate of the ijth entry. Understand? Ijth entry of a bar is nothing but conjugate of ijth entry. Understand? Ijth entry. This is true for every ij. Suppose you are going to get this. Example number 1. Suppose you take this. Suppose your matrix is, you can take any I, 1 plus I, 3, 2, minus I, 1 plus 5I. What is the conjugate of this? Just taking the conjugate of this. 2 bar minus I bar 1 plus 5 bar 5I bar. That means 1 minus I, 1 minus I, 2 I. Conjugate of minus I is nothing but I, is nothing but 1 minus 5. So this is my conjugates. So conjugate or simply is nothing but what is a matrix is obtained from the conjugate of the elements, corresponding elements of the given matrix. Write it, right? What is a conjugate? Conjugate of a matrix obtained from a given matrix by taking the conjugate, or else by taking conjugate the corresponding elements of given matrix. Corresponding elements of given matrix. So this is nothing but a conjugate, right? Suppose what are the properties generally? So these are very very important. Why? Because ఇప్పుడు తెలియదు యాక్చువల్లీ దీని ఇంపార్టెన్స్ ఎప్పుడు అంటే ఐగన్ వాల్యూస్, రైట్, ద ఐగన్ వెక్టర్స్, diagonalizable. Suppose I am going to give a Hermitian matrix. Is it diagonalizable? Right? Is it actually what is the minimal polynomial for that? So what is the Jordan block for that? Yeah, అప్పుడు తెలుస్తుంది దీని ఇంపార్టెన్స్. ఇప్పుడు తెలియదు. ఇప్పుడు ఏంటంటే సింపుల్ కనబడుతుంది యాక్చువల్గా, సింపుల్ డెఫినేషన్ మామూలు కనపడుతుంది. But the thing is that when you want to discuss about linear algebra, there are lot of applications. Right? So what is the first property generally? Conjugate of a plus b is nothing but conjugate of a. Conjugate of a is nothing but a itself. Conjugate of a scalar multiple of the matrix is nothing but conjugate of a into conjugate of a. Next is conjugate of a power n is nothing but in a conjugate whole power n, where n is a positive integer. Right? So these are important properties. Right? So it actually use just some general. Suppose you are given a matrix. Suppose you are going to give like a matrix like this. Right? Hermitian matrices. Suppose a theta equals to theta itself. Right? ఇది అప్పుడు తెలుస్తుంది అన్నమాట దీని అప్లికేషన్. సపోజ్ ఏ is a matrix of 2x2 matrices over R. Question is it a vector space అని అనుకోండి, is it a vector space over C అని అనుకోండి, is over C అని అనుకోండి, అప్పుడు తెలుస్తుంది. ఎందుకంటే ఈ ప్రాపర్టీ ఫెయిల్ అయిపోతుంది అన్నమాట. ఈ ప్రాపర్టీ ఫెయిల్ అయిపోద్ది. అండర్స్టాండ్? ఓవర్ సి అంటే ఫెయిల్ అయిపోద్ది అనమాట. ఓవర్ సి అన్నప్పుడు ఆటోమేటిక్ ఏమైంది, కే బార్ యాజ్ ఇట్ ఈస్ అట్లే ఉంటుంది. కే బార్ ఏమైంది, యాజ్ ఇట్ ఈస్ అట్లే ఉంటుంది కాబట్టి కే బార్ ప్రాబ్లం వచ్చేస్తుంది. సో దెర్ఫోర్ ఇట్ ఇస్ నాట్ ఇన్ జనరల్, ఇట్స్ నాట్ ఎ వెక్టర్ స్పేస్ ఓవర్ సి అనమాట. సో దీస్ ప్రాపర్టీస్ ఆర్ వెరీ వెరీ ఇంపార్టెంట్. రైట్? to remember this practice. Next is conjugate transpose. Conjugate transpose of a matrix. So generally your matrix is actually what? M by N matrix. Your conjugate of a matrix, conjugate transpose of a matrix, denoted by, in some books, a theta is defined as a theta is equals to conjugate of a whole transpose. Conjugate of a whole transpose. Conjugate of a whole transpose. That means transpose of a conjugate. Transpose of a conjugate. Suppose you are going to give a simple problem. Suppose your same problem 1, 2, suppose 1 plus I, 1 plus 5I minus I. Right? What is the conjugate of it? Conjugate transpose of a matrix? Simply A bar whole transpose. That means 1, 2, 1 minus I. What is the conjugate? 1 minus 5I. What is the conjugate? Minus I. What is the conjugate? Plus I. Whole power transpose. That is nothing but 1, 2, 1 minus I. Is nothing but what? 1 minus 5I minus I. Is nothing but what? Conjugate transpose of a matrix. Conjugate transpose of a matrix simply is nothing but what? Transpose of a conjugate. Transpose of a conjugate. Right? Suppose properties. Right? Suppose you are given a matrix. Suppose you are given a two matrices A and B which are same order. First, conjugate transpose of the sum is equals to sum of the conjugate transposes. Conjugate of a conjugate transpose of sum is equals to sum of the conjugate transposes. Next is k into a whole conjugate. That means k into a whole power theta is equals to k bar into a power whole theta. That means conjugate transpose of k is equals to k bar into conjugate transpose of a. Next is, suppose you can take this a power n ab whole power theta. That means what? Conjugate transpose of ab is equals to b conjugate transpose of a b into conjugate transpose of a. It's also important property. Right? Next is, suppose fourth problem, a power n whole theta. That means what? A theta whole power. It's also simple property. So you need to prove it by taking simple example. You need to exercise. It is an exercise, right? Simply one can prove it. Right? Next is what? Transpose of a matrix. What is the transpose of a matrix? Suppose you take a m by n matrix. What is transpose? You know, transpose of a matrix simply denoted by simply it's a matrix obtained from A by interchanging the rows and columns. By interchanging rows and columns. Suppose your matrix is suppose 1, 2, 3, 4, 5, 6. This is 2 by 3 matrix. What is n transpose? You know, on this all that basic matrix theory. So this is 3 by 2 matrix. This is A transpose. And next properties. A transpose whole transpose is equals to A itself. Next, AB whole transpose is equals to B transpose into A transpose. Next, third one, A plus B whole transpose. In fact, A plus B plus or minus B whole transpose is equals to A transpose plus or minus B transpose. Fourth one, A power n whole transpose is equals to A transpose whole power n whenever n is a positive integer. Next is K into A whole transpose is equals to K into A whole transpose. K into full transpose where k is any real number or complex number. Right? These are the important properties. Right? Next is trace. Trace of a matrix. What is trace of a matrix? Suppose you're going to take a square matrix. It should take a square matrix. You should take a square matrix of order m by n. So trace of a matrix simply denoted by trace of a matrix A simply denoted by trace of A or TR of A. So what is my definition? Is sum of all its diagonal elements. All its diagonal elements. That is simply is nothing but I equals to 1 to n. Sum of all diagonal entries. Sum of all its diagonal entries. Right? Suppose you're going to give an example. Suppose A equals to 1 0 0 0 1 0 0 0 2. What is its trace? Trace is nothing but sum of all its diagonal entries. That is nothing but what? 1 plus 1 plus 2. That is nothing but 4. Right? Suppose your matrix is 2 sin x, right? 1 0, right? 0, right? 5 cos y, right? 3, next 7, 4, 3 sin z, right? Here, so your values x, y, z, that element, that angles are should be sitting inside 0 to pi. Suppose trace of A, if trace of A is, suppose you are going to give actually what is this? Suppose your trace of A is 10. So find the value of trace of matrix, diagonal matrix 8 tan x by 2 minus 5 sin square x sin square y minus cos z 6 cos z. Understand? Your given trace of A is 10, right? Trace of A is 10. What is the trace of diagonal matrix 8 tan x by 2 5 sin square y minus 6 cos z? Anybody? What is the answer? What is the trace you are given? Your given trace is trace of A is equals to 10. What is the sum of diagonal elements? Sum of diagonal elements. That means 2 sin x plus 5 cos y plus 3 sin z is equals to 10. Tell me, what is the implication? This can be rewritten as, this can be rewritten as 2 common 1 minus sin x can be written as 2 plus 5 plus 3. 10 can be written as 2 plus 5 plus 3. So here 5 common again, 1 minus cos 5. Here actually what? 3 common, 1 minus sin z equals to 0. This is non-negative. This is also non-negative. This is also non-negative because sin is bounded by plus 1 and minus 1. Yes or no? Therefore, 1 minus sin x should be non-negative. Similarly, cos also bounded by minus 1 and plus 1. Therefore, 1 minus cos y should be non-negative. Therefore, this is non-negative, this is non-negative, this is non-negative. Sum of non-negative is 0 if and only if each individual term is 0. Right? Therefore, sin x is equals to 0, sin x equals to 1, cos y equals to 1, sin z is equals to 1. So, your angles are bounded by 0 to pi. Therefore, what is the actually solution for this? X equals to only pi by 2. What is the angle here? 0. What is the angle here? Pi by 2. Therefore, dia of 8 tan x by 2. Tan x by 2 means pi by 2. Pi by 2 means pi by 4. 8 5 sin square 0 minus 6 cos z means cos pi by 2. Therefore, dia of tan pi by 4 means what? Tan 45, that is 1. Sin 0 is 0. Cos 0 is 0. So that is nothing but what? Dia of 800 is nothing but what? 800, 000, 000. What is the trace of this? Trace of dia of 8 tan pi by 4 pi sin square 0 minus 6 cos pi by 2 is nothing but what? 8 plus 0 plus 0. What is the answer? 8. Is it clear? Hello?
Yes, sir.
Yes, sir.
So this is important trick. So, sum of non-negative is 0 if one non-negative, each piece is 0, each term is 0. Right? Next is, suppose you are given a question. A equals to -5, -8, 0, 3, 5, 0, 1, 2, -1. 1, 2, -1. You are asked to find what is the trace of A plus trace of A square plus trace of A cube plus trace of A power 100. The answer. Trace of A plus trace of A square plus trace of A cube plus going on trace of 100. Anybody? A equals to -8, -5, -8, 0. B equals to 3, 5, 0, 1, 2, -1. Okay. What is the trick?
99.
Right? So what you are given, actually you need to find A and A square and A cube and A power 100. That is the trick. So A already you are given, so you need to compute A square. What is A square? -5, -8, 0, 3, 5, 0, 1, 2, -1, -5, -8, 0, 3, 5, 0, 1, 2, -1. Right? Yeah, tell me, what is it? What is it? 25 minus 24. Next 40 minus 40. Right? Next 0, 0, 0. Next -15 plus 15. Next -24 plus 25, 0. Next -5 plus 6 -1 -8 plus 10 -2 0 0 plus 1. So what you're going to get? 1 0 0 0 1 0 0 0 1 is identity matrix. Therefore, similar already told you A cube also 1 I, A power 4 also I, A power 100 by induction, A power A also I. Therefore, what is trace of A? Now tell me, what is trace of A? Trace of A square. Trace of A power 100. What is it? Tell me. What is trace of A? Trace of A is nothing but -5 plus 5 plus -1. What is trace? -5 plus 5 plus -1. That is -1. So trace of A is -1 plus what is trace of A square? Trace of A square is identity matrix. Therefore, trace of A square is nothing but 3. Next, trace of A power 3. What is A power 3? What is A power 3? Sorry, A, right? Sorry, I forgot. What is trace of A? A, because A cube is nothing but what? A square into A. What is A square? I into A. This is nothing but A. Sorry. A power 4. What is A power 4? I. A power 100 means A. Right? So therefore, so this is nothing but what? A power 3 is nothing but A. What is the trace? What is A square? Sorry. What is A square? A square is nothing but I. Therefore, this is 3. What is A cube? A cube is nothing but A. Therefore, you are going to get -1. What is A power 4? 3. What is A power 5? -1. Going on. What is A power 99? What is A power 99? -1. What is A power 100? 3.
3.
So how many these? How many -1s? Exactly half right, half right, half right,
100.
right? -50 plus 150. What is that? 100. Is it clear? Right, exactly half of the terms are 50, half of the terms are 50. Therefore, 50 into minus 1, 50 into, therefore, this is nothing but 100. Right. Next is I'm going to give some properties about this trace are very, very important when I teach like linear transformations on, you know. So trace is always linear. Look at the properties of trace. First property, trace of a plus b. Trace is always linear. Trace of a plus b equals to trace of a plus trace of b. Next, trace of any scalar into a is equals to, you can take scalar as some k for sake of more convenience. It means, what is it? K into trace of a, where k is any scalar. Next, trace of, trace of AB equals to trace of BA. Next, trace of, so using this property, trace of AB, ABC can be written as, trace of, this can be rewritten as, by using this property, BCA. So no, this is, you can take it as some B into A. Similarly, you can take this as B. So trace of CA into B. Next, trace of A transpose is equal to trace of A. Next, sixth one is trace of A theta. Is it equals to trace of A? Anybody? Are they equal? Are they equal? Are they equal? Yes or no? Are they equal? Suppose you are going to take actually what? 1 plus I, 1, 1, 1 plus I. Right? What is A theta? Anybody? 1 plus I, 1 minus I conjugate 1, 1, 1 plus I conjugate. This transpose. That means 1 minus I, 1, 1, 1 minus I. What is trace of A? Trace of A is 1 plus I plus 1 plus I. That is 2 plus 2, 2i. This trace of A theta is nothing but 1, 2 minus 2i. Therefore, they are not equal. In general, they are not equal. Trace of A power theta may not equal to trace of A unless it is a real symmetric matrix. It is a real matrix. Real matrix. If real, A theta is equal to A power A transpose. Both are same. If it is real, both are same. If your field is actually what? R. The field is R, A theta is equal to A transpose. Right? But in general, they need not be equal when you deal with a complex field. Right? Next, trace of A for B whole K, where K is a constant. What is the trace? Anybody? Trace of B A whole power K. Why? Because trace of AB K can be written as trace of AB, 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 AB. You can take this, this can be rewritten as trace of BA, 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 this can be written as BA into B. But you can take this as a B by using this property. You can take this as some B or using this property, very important. Trace of AB equals to trace of BA. Using this property, this can be written as trace of BA, B into BA, 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 going on BA into A. Yes or no? Right? So therefore, what is this actually? What is this AB, BA, BA, this is BA, this is B, BA, what is this? B, I missed it. Sequence missed it. So therefore, this is BA, 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 this is my B, right? BA, going on, BA, B, and your A. Therefore, what is this? BA, 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 up to K times. So B is what? K. Right, this is also important property, right? Next is trace of, you know, we take trace of AB minus BA into trace of AB plus BA. What is this trace? You know, this can be written as trace of AB into AB whole square, AB into BA, next minus BA into AB, next plus, what is it, minus BA whole square, right? Is it right or not? BA whole square. So therefore trace of A plus B plus C is nothing but trace of A plus trace of AB BA minus trace of BA AB minus trace of BA whole square. You know, already I told you trace of AB whole power k is equal to this, both are same. Therefore, this can be cancelled by using this formula. Is it right? Therefore, this can be rewritten as, what is this? Trace of AB. What is this? BA minus trace of BA AB. That's it. Right? Next is trace of, right? Trace of, suppose you're going to take which example? Enough, these properties are enough, right? So with this, the trace is completed. Suppose మీకు ఇది కూడా ఇంపార్టెంట్ యాక్చువల్గా మీకు ఇన్వర్టబుల్ మ్యాట్రిక్స్ చెప్పలేదు కానీ trace of PA into P inverse is nothing but trace of A when P is invertible matrix. Why? Because trace of PA P inverse, this is like looking like B, you know. Trace of AB is equal to trace of BA, but it is invertible. Trace of A into P inverse is nothing but I trace of A. Right? Whenever in P is invertible, trace of PA P inverse is equal to trace of A. This is also important argument. Right? So with this I conclude. Okay, is there any doubt? Tell me. With this I conclude the class. Is there any doubts?